Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will learn about the programming logic of motion control cards. Our lesson will cover the following 4 main topics. Through this lesson, you should be able to understand the basic concepts of motion control card programming logic, its framework, and the function of each component. You will also learn to implement the programming logic of motion control cards, including sequence control, conditional control, loop control, and the use of functions and subroutines. Programming logic is the core of automation control for a motion control card, determining how the motor responds to external commands and completes various complex motion tasks. Let's begin with the basic concepts of programming logic. Programming logic, simply put, is a set of instructions and conditions used to direct a computer or controller to execute specific tasks. In motion control card programming, these instructions and conditions are typically related to the motor's movement status, position, speed, and other parameters. 2. Programming framework of motion control cards. A typical motion control card programming framework usually includes the following components. 1. Initialization module sets the initial state of the control card, including communication parameters, I/O port configuration, and motor parameters. 2. Motion control module contains various control commands for movement, such as start, stop, accelerate, and decelerate. These commands are often associated with the motor's trajectory and speed curve parameters. 3. Status monitoring module monitors the motor's movement status in real time, such as current position, speed, and temperature, and adjusts the control strategy as needed. 4. Exception handling module manages potential issues during operation, such as overcurrent, overheating, and communication faults, ensuring system stability and safety. 3. Methods of implementing programming logic. 1. Sequence control executes a series of instructions in a predetermined order to achieve gradual motor movement. This method is suitable for simple motion tasks like linear motion or fixed point positioning. 2. Conditional control selects different instructions based on changes in external signals or internal status. For example, if a sensor detects an object, the motor begins handling. If the motor reaches a designated position, it stops. 3. Loop control repeats a series of instructions until a certain condition is met. This is commonly used in scenarios that require periodic motion, such as continuous processing or cyclic inspection. 4. Functions and subroutines encapsulate complex control logic into functions or subroutines for easy calling when needed. This improves code reusability and readability while reducing programming difficulty. 4. Optimization techniques for programming logic. When programming a motion control card, consider optimization techniques to improve efficiency and reliability. 1. Reduce redundant code. Avoid writing duplicate code by using functions, subroutines, or macros to minimize redundancy. 2. Optimize algorithms. Select efficient algorithms for calculating motor trajectories and speed curves to reduce computation time and resource consumption. 3. Set parameters reasonably. Adjust control parameters like acceleration, deceleration, and maximum speed based on the motor's performance and control requirements to ensure smooth and accurate movement. 4. Strengthen exception handling. Improve exception handling mechanisms to quickly detect and address issues, preventing system crashes or damage. Through today's lesson, we have gained an in-depth understanding of the programming logic of motion control cards, including its basic concepts, programming framework, implementation methods, and optimization techniques. I hope you will apply this knowledge to real projects, continually improving your programming skills and enhancing your ability to design automated control systems. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.